guys, this is the fourth part of the video on titration calculations. So far, we've looked at calculating concentrations in moles per decimetre cubed. But we can also measure our concentrations in units of grams per decimetre cubed. And we can convert a concentration in moles per decimetre cubed to a concentration in grams per decimetre cubed using the following equation, which is that our concentration of a solution in grams per decimetre cubed is equal to the concentration of that solution in moles per decimetre cubed multiplied by the relative formula mass of the solute, which can be written in shorthand as the MR value. Let's look at an example, which is what is the concentration in grams per decimetre cubed of a solution of NaOH or sodium hydroxide, which has a concentration of 0.7 moles per decimetre cubed. If we look at our equation for concentration of a solution in units of grams per decimetre cubed, we can see that we need to know the relative formula mass or MR value of the solute. So for this question, we need to work out the MR value of NaOH, sodium hydroxide. If you've watched our video on relative formula mass, you'll know that the relative formula mass of a compound is equal to the sum of the relative atomic masses of the component atoms, where the relative atomic masses can be found in the periodic table. So in this case, the relative formula mass of NaOH is going to be equal to the relative atomic mass of sodium, which you can find in the periodic table as 23, plus the relative atomic mass of oxygen, which is 16, and the relative atomic mass of hydrogen, which is 1, which gives us a grand total of 40. We can then use our equation to find our concentration of sodium hydroxide in grams per decimetre cubed, which will be equal to our concentration of sodium hydroxide in moles per decimetre cubed, which was given in the question as 0.7, multiplied by our relative formula mass, which we just calculated as 40. If you calculate 0.7 multiplied by 40, get 28. So our concentration of sodium hydroxide solution in grams per decimetre cubed is 28 grams per decimetre cubed. We can think of this as if you needed to create a solution of 0.7 moles per decimetre cubed.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE chemistry and combined science videos, just click on the Snap Revise smiley face. Join me today and together let's make chemistry at GCSE a walk in the park.